Let's look at the area of a surface that's represented parametrically. Earlier, we had a Cartesian formula for computing surface area. So now what we want is an analogous formula to do the same computation. So we have a surface represented by the following parametric representation: 2u cosine v, comma, 2u sine v, comma, u squared, where u runs from 0 to 2 and v runs from 0 to 2 pi. Now, the formula for the area when we use the parametric representation is simply the double integral over the region R of the norm of the cross product here. And of course, this is our friend. This is actually the norm of the surface normal. And so this is a computation we do often when we do surface integrals. So we need to get very accustomed to it, especially since we will be studying Stokes' theorem. And of course, just the basics of surface integrals. So what I've written here is analogous to Cartesian formula. So first what we need to do is compute RU cross RV. And so that's not too hard to do. So of course we want to do a U partial of R. That'll give us a 2 cosine V, a 2 sine V, and of course a 2U. And then of course we need a V partial. So we're going to have a negative 2U sine V. Then we'll have a 2u cosine v as we have here, and then of course the v partial here will just be 0. And so this is more analogous to the sphere computation which I referenced earlier. We have to be careful with the sines and the cosines and respect that. And so now we want to do the cross product, so we'll do 2, 3. So we have 2, 3, which gives us a 0, and then the 3, 2 here will give us a negative 4u squared cosine v as we have here. And then we need 3, 1. So 3, 1 will give us a negative 4u squared sine v as we have here. And then of course the 1, 3 that we have here gives us a 0. So this is all that survives. And then for the last coordinate, and let me write that up there to remind you, this is 1, 2 minus 2, 1. So we have 1, 2. That will give us a 4u cosine squared v as we have here. And then minus 2, 1. So minus minus will give us a positive 4u, in this case, sine squared right there. So we have to be careful with the powers and just be very vigilant about checking the cross product. It's very easy to make careless errors. And so now, of course, I'm going to be lazy. I don't like all this extra stuff hanging out in the cross product. So we've got a 4u in all of these components. So I'm going to extract a 4u, leaving behind a negative u cosine v, a negative u sine v. And of course here, when we look here, we just have cosine squared plus sine squared v left over, and that's just 1. So that was really useful to do. And now we can take the norm of this. We have the absolute value of 4u, which by definition will just be 4u. And then we square out the components. So we're going to have a u squared cosine squared plus a u squared sine squared plus a 1. So that's just going to give us u squared because of the fundamental identity plus the 1. So we have the square root of u squared plus 1. So we go back to the fundamental trig identity all of the time when we do these types of computations. But this will be the integrand as we see from our formula. So now the area will actually be the double integral over this region. That is, v runs from 0 to 2 pi, u runs from 0 to 2, and we have the 4u square root of u squared plus 1. So again, all of this computation here is contingent on the computation of the norm of the surface normal. But this is a nice Cal-1 integral. So the chain rule says we need here a 2u, and we've got a 4, so I'm going to borrow 2 from the 4. That is, pull out the 2 and leave the other factor of 2 right here. And of course, this integral here has no v dependence, so we can split these up. So we'll have 2, the integral 0 to 2 pi dv, and then of course now this is table ready, add 1, divide by the new power. And so of course this will give us 2 pi times the 2, which is a 4 pi. the new power is 3/2. Division by 3/2 is multiplication by 2/3. And of course, we evaluate between 0 and 2. So this is just calculus 1 at this point. And so now, of course, this will give us an 8 pi over 3. And when we evaluate it 2, we'll just get a 5 to the 3/2, and evaluate it 0, 1 to the 3/2. So our final answer will be 8 pi over 3 times the quantity 5 root 5 minus 1. So I want you to look at this problem and study it and make sure that you understand the computation that we're doing, because we will do this over and over in the remaining sections that we have to cover. And we are done.